Good afternoon, everyone. On behalf of the Shardus team, that you see, and we have some team overseas as well, but on behalf of the Shardus team, I'd like to welcome you all to the Q1 2019 update of our project. So thank you so much for coming. Normally, these quarterly updates, what is the purpose? The purpose of these updates is primarily for three things. Number one, to hold ourselves accountable to our commitments. Without the commitment, without committed action, there's nothing. So we committed, every quarter we commit to something, and then we go away, and then we work, and we come back, and we present the progress. So this is holding ourselves accountable to you all. That's number one. Number two is to show the progress, demo what we have, the current state of the project, where we are today, what have we done, what we have missed, and we be very transparent. Okay, this is what we committed, this is what we have this quarter. So this is a good way for us to keep ourselves accountable and on track and keep you involved in the project. There are many supporters of the project, so this is really critical for them to see what the progress is and where the technology is headed. So that's one of the reasons that we have. Then one of the reasons is bringing awareness to this new technology, blockchain or distributed ledgers or trustless consensus. This is going to revolutionize many industries. And I'm sure many of you all know, but of people who are not aware of this technology, this is something to pay attention to. This is going to change how the financial industry, the supply chain, the healthcare is going to impact across the board, how that systems are going to get built, primarily because of the distributive nature of this technology, trustless consensus and whatnot. So this is another reason why we are here, to bring an awareness of this technology. This is going to change how we look and perceive things in the future. To begin with, we're going to play a small introduction video of what Shardus is.
So my name is Omar Sayeda, and I'm one of the team members on the Shardus project. And my background is in computer science. I've worked for various different large organizations and also small startups. I sort of kind of accidentally got into the distributed systems area when I was working at NASA. Learned quickly how to, scale up web services and things like that. And I used that to help other internet startups with scaling up their back-end services. 2009, when Satoshi released the Bitcoin software, at first, people didn't really quite realize the deeper potential of what he had released, solving a very difficult problem that hadn't been solved before. This breakthrough, what it allows you to do is be able to have multiple parties being able to interact with each other over that same database. And so that's pretty big. If we can still maintain that capability of Bitcoin while increasing the scalability and reducing the energy consumption, then that's kind of like the holy grail. In distributed systems that I've built in all these years, the key technology used to do that kind of scaling is called sharding. And you have different groups of nodes process different transactions or process different data, and that way you get parallelism. So what we're trying to do is build that scalability at the core level, right? So that's usually referred to as like on-chain scaling. We're designing our system to scale as more nodes are added to the system. That should allow us to be able to get to a point where we have distributed systems that can scale linearly, meaning as more nodes are added to those systems, the transactions per second goes up. So we now are looking at transactions per second per node rather than a fixed transactions per second. So once we have that technology, then it's a matter of building applications on top of that. And so the easiest application to build is just a payment network. We refer to that payment network and coin as Liberdis. Whenever you're trying to build a new technology, it's a tough problem, and you're going to need a lot of smart people to be able to work on that problem. And a typical approach that a lot of other projects are taking is that they'll create what's called an ERC20 token, and then they'll sell that token to raise funds. So we are not doing any kind of sale of our token to the direct public or to investors or anything like that. We are using our own tokens to give to the developers for contributing code and for doing bounties, and other things that help the project. Shardus is building the foundational technology for global scale applications.
I hope that gave a quick teaser of what Shardus is. And now I'd like to introduce you to the man behind this project. You've already seen him. I'm going to talk a little bit about his background a little bit and how I know him. I've known Omar Sayeda for over 20 years now. Pretty much he's my mentor in terms of guiding me in technology and what to do in my career and whatnot. His academic background, I've always found him to be a visionary. I've always seen him. Back in '95, he would tell me that people are going to order stuff online like houses, get married, find their matches online, etc. I'm like, no, that ain't happening. But soon enough, he built a matrimonial site, and then there it goes. And then it kept going on and on and on. So I was like, wow, this guy knows what he's talking about. So I started to follow him blindly. Now, next thing, his academic background. His academic background is in neural networks. His neural networks, that's where his academic background is. And he has spent majority of his experience in building large-scale distributed applications at companies at NASA, at Yahoo, at Zynga. All of these companies are, as you can tell, are technology companies solving major problems. His last innovation was a board game called Arima. It's a game that's easy for human beings to learn and play, but it's harder for computers to learn and play because of the speed and whatnot. So that game is still around, but then after that, now it is Shardus. So Shardus is here. This is a technology. He spent lots of years on this one. So it'd be interesting to hear from him what he has to say. Without further ado, I'd like to introduce you to Omar Sayeda.
Well, thank you very much, Samir, and thank you everyone for coming out. It's been a kind of a terrible weather-wise day, but really excited to see that so many people have come out. Basically, as Samir said, the Shardus project does an event every quarter just to let everybody keep up on what we're doing. We're just a bunch of developers, and we don't sit there tweeting and posting and trying to raise hype about the project. We keep our head down and develop. And every quarter, then you'll see us come out and tell you about what we've been doing. You've all probably by now have heard about cryptocurrencies and blockchain. And this definitely is a very revolutionary technology, and it's happening right now, and you're living right through it. And I know there's some people that kind of think it's a fad, and this is not going to last or it's going to go away. But if you think along those lines, you're going to miss out on one of the most important technological changes that's happening in our lifetimes. It's going to impact a lot of different industries and different sectors of the industries. And one of the biggest one that's going to be impacted is the financial sector. So if you work in the financial sector or anything like that, you should definitely be keeping an eye on what's happening. But other areas that are going to be impacted are, like insurance, transportation, cloud computing, healthcare, energy, entertainment, retail, real estate, voting, probably even government, through laws, identity, credit, a lot of different things. So basically anywhere where in our current economy where we have a third party that you trust to carry out something for you, over time what's going to happen is those third parties are going to get replaced by a peer-to-peer network. And you're going to, you can't get rid of trust, but rather than trusting some humans or a company that's very centralized, you're now going to put your trust in a network of decentralized computers. So you're going to trust that instead of trusting any one company. And you may even be able to participate directly by adding computing resources to that network. The other day, I got this in the mail, and it's basically a notice about a class action lawsuit. So let me read to you like what it says here. It says, this lawsuit is about claims that merchants paid excessive fees to accept Visa, MasterCard, because Visa and MasterCard individually and together with their respective banks, member banks, violated the antitrust laws. And this is a lawsuit for $6.5 billion. Okay, so, you know, we basically trust these companies like Visa and MasterCard to charge our credit cards, and the merchants expect that they're gonna cut out the appropriate fees and deposit the rest in our bank account. But if they didn't, who's gonna check, right? And so they've been skimming on that, and over time, you know, they've skimmed off billions of dollars. And so this is an example of where, you know, we place trust in third parties, but then they violate that trust, or, you know, sometimes humans are involved and they make mistakes. And so over time, we're gonna move away from that and over to using peer-to-peer networks. So since I'm gonna be mentioning this word like peer-to-peer networks or just networks a lot of times, wanted to give you kind of an idea of what we're talking about. So basically in a peer-to-peer network, you have lots of different computers that can be run by different people, and they're all around the world, and they're connected to each other over the internet. And each computer is holding a copy of the same database. And outside, you have the clients who are trying to make transactions into those networks, and when they submit those transactions, the transaction gets propagated to all the nodes in the network. And if the transaction is valid, then every node will update its database. So you really have to convince all of the nodes in the network that what you're trying to do is valid. And, you know, we use cryptography to do that, and the other part of it is, you know, just the business rules of what you're trying to do. So if, for example, if I run a node in the network, I also have a copy of that whole database, but I can go and edit my copy of the database to say I have 1 million coins, and then I can submit a transaction into the network to spend my 1 million coins, and my computer will accept it, but once that transaction gets sent to the other computers, none of those guys will accept it. And so what the majority of the network thinks is true is really what truth is. Okay, so that's very important to remember with these peer-to-peer networks. So to kind of give you a comparison about, like in the financial industry, how, you know, this is impacting things, and, you know, you've probably heard about Bitcoin, and, you know, you've seen the Bitcoin price rise like astronomically, and people are saying, oh man, the price is way too high and so forth. Well, I'm gonna show you that the price is actually in line with what it should be. So Bitcoin is not only an asset that you can transfer over the internet, but it's also a payment network, right? So what's another example of a payment network? So PayPal is a payment network. But PayPal doesn't have its own coin. They use, the existing fiat currencies, whether it be US dollar or euro or whatever. But they're providing the payment network only. Now, you can get some ownership in PayPal. They're listed on the stock market, so you can go buy shares and own that company. When you buy Bitcoin, you're not only buying Bitcoin, but you're also buying ownership in the Bitcoin payment network. And your coins are a representation of that ownership. So if you look at it that way and you say, well, PayPal has a market cap of $125 billion. It's been around for 20 years, has 270 million users. In that terms, when you look at Bitcoin, its current market price is about $90 billion. It's been around for only 10 years, and it already has 32 million users. So when for things that are growing exponentially, 32 million users is actually not that far away from 270 million users. So in a much shorter amount of time, Bitcoin has grown much faster. And if you also look at the fact that it's international, right? And so anybody can use it around the world. So that payment network is what's giving Bitcoin its real value. So what are some of the other kind of decentralized networks that we can expect to see in the future? We believe that, maybe 10 years down the line or so, that we'll actually have a global currency, and that currency will be run on one of these decentralized networks. And it'll be a currency that, it might not be Bitcoin because Bitcoin is too volatile, but it'll be a currency that's more stable. And because it's stable, you'll be able to, use it in transactions and expect to, not have that price volatility affect your trade. We also expect that in the long term, there'll be global identity networks. Right now, people's identities are scattered all over the place, and you don't actually have any control of your identity. There's a lot of silos that have pieces of your identity, but you yourself actually don't have control over your identity. So eventually, these kind of networks will allow us to have our identities stored on a decentralized network and have direct control over that and manage who can look at that. We'll also be using these for global communication networks. So like right now, if you think about, like WhatsApp or Telegram, there's all these different siloed communication systems that are out there. But really, it would be awesome if we had like one system and everybody could use that to communicate, and there's like really no company behind it. You'd really want these things to be like a utility that's not owned by anybody. It should be just like a public utility and be completely decentralized, so you don't have to worry about, well, what if this company goes rogue, right? So, and of course, social networks and things like shopping networks, social network, Facebook, and Facebook is starting to look into getting into blockchain. Shopping networks, I'm sure Amazon is going to have to look into it really soon. But these are all things that could eventually become like public utilities, really. So what is Shardus, and how do we fit into this bigger picture of what's going on in this space right now? So Shardus is structured as an association. It's a group of people coming together towards a common goal. And anybody that contributes to the project is basically part of that association. It's a lot of the open source software that's out there has been built under that model. People don't specifically realize it. For example, Linux. I mean, we have it, if you have an iPhone or Android, underneath there's Linux software. Well, where's the company that built that? Well, there is no company that built that. It was just built by a bunch of people, collaborating over the internet and working together to make that software possible. So Shardus is similarly structured, and we're building the software that's going to make it easy to create and deploy these peer-to-peer networks. And currently the software is closed source, but long-term it's going to be open source so that anybody can take a copy of that software and launch their own network from it. And networks that are built using Shardus will benefit from having a lot more scalability, decentralization, and energy efficiency, which the current systems out there, they were kind of built like really fast and without like really thinking through all the trade-offs that could be made in building those systems. So I mean, it's good that they did that because it got things rolling, but it's also kind of like we may be caught in a local minimum, and there's better solutions out there, and unless we explore the space more, we're not going to find those better solutions if we all just converge to some local minimum and just stick to one solution. So Shardus is kind of stepping back and designing our system without launching it right away and trying to create a lot of hype about it. We're sitting back and designing it and building it the right way so that we can build the best system possible. So as I mentioned, our goals are to achieve greater scalability, more decentralization, and energy efficiency. And while you're doing that, it's really important to maintain a high level of security. So there's actually trade-offs between these things, where sometimes if you try to increase one, you'll get some lose something in another. So in terms of scalability, what scaling really means is that if you add more nodes to your network should be able to process more transactions or be able to have more capacity in terms of the data that it holds. All the networks that are out there right now, like Bitcoin, Ethereum, EOS, all these networks, they're not really scalable because it doesn't matter if you have 100 nodes in your network or 10,000 nodes in your network. It doesn't actually process more transactions or has the capacity to hold more data. In fact, it actually creates more network traffic because now every transaction has to get sent around to every node. So there's projects out there that are doing transactional sharding. For example, Ethereum has announced that they're going to do transactional sharding. There's a project out there called Zilliqa, which is doing transactional sharding. Transactional sharding buys you a little bit more speed, but transactional sharding doesn't get you linear scalability. If you want linear scalability, you have to do state sharding. And state sharding is very hard because that means a node will not hold all of the data. The data will be spread out across different shards. And so that makes it extremely hard. And when you're structured as a blockchain and the blockchain has to hold all the records, it gets really complicated to figure out how you're going to handle that. Another aspect is the decentralization. And with decentralization, what that means really is who's running the nodes. As I mentioned in that image that showed you all these nodes that are interconnected to each other around the world through the internet. And anybody can add a computer to join that network. Well, who's actually running those nodes, right? So you actually do want lots of unrelated parties to run those nodes. Otherwise, if one person is running all that or one company is running all that, then that's not very decentralized. That's still centralized. So it's very important to have different unrelated parties running that. Another thing you want is that the parties running that should have some stake in that network in terms of, hey, I don't want to just like add resources to this network and then suddenly go rogue and steal the money or something. I should be invested in that network. So that's very important. So the key to doing that, what Shardus does is we have a feature called node rotation, where you can actually have nodes coming into the network and then going out of the network. And that's combined with what we refer to as auto scaling, where the network monitors the load that it's seeing and can decide how big the network should be. Like, you don't really want the network to be, 1 million nodes if you don't need it to be that big. What's the point of it, right? I mean, you're just spending a lot of resources if you don't need the network to be that big. So our networks auto scale to adjust to the load. But there could be more people that want to join the network. And so our nodes automatically rotate out nodes and let other nodes join the network. And another key important thing is that people should be able to use off-the-shelf computers to join the network. With networks like Bitcoin and Ethereum, they're struggling to try to maintain that because underneath they're using what's called proof of work, and that really amounts to doing lots of hashes. And people have figured out how to build like specialized computers to do way more hashes than a regular computer can. And so you can just buy specialized hardware and then be able to join the network using that and get a lot more reward from the network. And it kind of like squeezes out the individuals from being able to join and participate in that network. So Shardus is actually set up so that we don't use any proof of work kind of consensus. So that'll allow people to be able to join the network using off-the-shelf computers. And along with that it's very important that you maintain a lot of energy efficiency. When Bitcoin came out, it showed us how to do unbounded consensus. But one of the trade-offs with that was that it used a proof of work consensus, and that ends up using a lot of energy. And people have started to question, do we really need to spend that much energy to achieve consensus? And there are different ways of achieving that. There's proof of stake, and in the long run, having a system that's more efficient, I think, will win out. Because if you look at any kind of systems in the natural world, things tend towards greater efficiency. So if you have two networks where one is spending a lot of energy and another network that provides the same feature but spends a lot less energy, well, that means the transactions on that more efficient network can be a lot cheaper. So right now, Bitcoin is spending about $70 million keeping that network running. I mean, those guys got to get paid somehow. So eventually it's going to have to come from your transaction fees when the block rewards start running out. So Shardus is using what's called a proof of quorum, which simply means that you identify who's involved in making it, the group of nodes that are involved in making the decision about whether something is accepted or not. And you simply check to see if a supermajority of those nodes have agreed on that transaction. And so it's quite simple in a sense, but it achieves consensus without having to expend a lot of energy. And also, as I mentioned, auto scaling, that helps us reduce the energy. You don't want to have your network be really big when you don't need it to be. So, this is all good and fine, but how does a project like Shardus go about building this and fund the building, right? Because at the end of the day, there's people that have to work on this code and they have to live, right? And so they've got to pay bills and so forth. Now, the interesting thing about what's happening with this revolution in blockchain is this concept of tokenization. So tokenization basically means that you can create things of value and be able to transfer them on these networks that are already out there. And so Shardus is kind of in a sweet spot because we're not too early. And so there's already been some networks ahead of us, such as Ethereum, for example, that already provide a way for us to create tokens on that network and transfer those tokens. And that transferability is very important. So Shardus has created tokens on the Ethereum network. So there's a standard out there called ERC20, and it basically defines a way for you to be able to transfer tokens between two people. And the Shardus tokens are set up so that we have a contract on the Ethereum network. And the contract has a function on there called a purchase license function. So the tokens that are being created, we're directly giving those tokens to our developers and promoters and anybody who helps, with the project. Now those people that receive the tokens can use those tokens to purchase a license, or they can sell those tokens to somebody else that wants to purchase the license. And so over time, as the Shardus software is built, those tokens will become more and more, real in terms of, hey, these are going to be needed if we want to get a license to the Shardus software. So in a sense, the tokens kind of represent your ownership in the Shardus software. It's not an ownership as in a company or the association, because anybody can join the association, and there is no company, there's no shares, so the tokens really just kind of represent your ability to buy that software that's being developed. So the way the Shardus software works is that we're just creating this piece of software which can then be used to build other applications from it. So you can have applications that are built on it for private enterprises, and private enterprises will need to obtain a license token, and when they do, the tokens that they obtain will be sent to a purchase license function, and they'll get burned there, and then a license token will be issued to the sender. And so that's provable on the Ethereum network that you've obtained a license to the Shardus software. And those tokens that are burned will cause the supply of the Shardus tokens to reduce. And so over time, as the supply reduces, there'll be less tokens, and so its value would increase as other people need to buy those tokens. The other aspect of it is that public networks that want to use the Shardus software and build something from it can give their tokens or their coins back to the Shardus token holders. And that's like a win-win situation, because when you're creating a new network and you launch your network, you want people to come and join your network. So by giving the tokens to the Shardus token holders, you're actually, giving an incentive for those users to come and, participate in your network. And for those who are holding the Shardus tokens, it's kind of like, almost like a dividend that they receive from other networks that are being built using Shardus. So one of the first things that we're going to build using the Shardus software is a payment network which has its own coin in it called Liberdus. And that's, for example, like with Bitcoin, the technology underneath is blockchain. So in our case, the technology is Shardus, and Bitcoin is kind of analogous to Liberdus, right? So Liberdus is the coin part, and Shardus is the technology part. And we're designing this so that this network is able to self-sustain itself in terms of self-governance, in terms of having a maintenance fund which can be used to continue the development of the software. And the Shardus token holders will receive Liberdis coins when that network is launched. And one of the things that you would need the Liberdis coins for is to actually participate in the network by running a node. So if you want to run a node, you're going to have to show that you have a stake in the network. As I mentioned earlier, you want people to have a stake in the network that they're participating in. So you're going to need to, acquire some of these Liberdis tokens to show that you have a stake in the network and be able to run a node that participates in the network. And for doing that, your node will receive some Liberdis tokens on a daily basis to kind of pay you for the services that you're providing. Another application that we want to build using Shardus long-term is something that we refer to as Ville. So Ville would be a decentralized identity network, and it will also have a stable coin, which we refer to as Getcoin. And it's interesting that you actually need to have decentralized unique identities in order to have a stable coin, and they kind of like go hand in hand. So Ville would also be built using the Shardus software, and similarly the Shardus token holders will receive the Ville coins once the Get coins once this network is launched. And similarly, you'll need to have those in order to run a node and become a validator in the network. So what's the roadmap for building out this technology? So in Q3 of 2018, we demonstrated our consensus algorithm. And Q4 of 2018, we demonstrated the first version of our distributed ledger. And we're referring to that software as the enterprise server, partly because for enterprises, that may be sufficient for them to actually, they probably don't need to scale to like global scale, but so they could use, the enterprise server to even maybe get started and experiment with this technology. Now this quarter, we've been adding more features to the distributed ledger, and we're going to demonstrate that for you shortly. Going forward, we need to add the state and transactional sharding, and the server that includes that we refer to as the global server. And then beyond that, we want to add complex transactions to it. So complex transactions are when you have transactions that affect multiple different shards, and it increases the complexity of how you handle those. So we refer to that as the universal server. And then once that's done, then the Shardus core technology is developed, and we can start building the Liberdis network on top of that. And actually, we may be able to start building some of the Liberdis software a little bit earlier as this technology starts to get developed. So there would be some parallel between building the technology and actually building the application with it. But we're hoping that by Q1 of 2020, we have a Liberdis testnet that we can launch. And then hopefully about 3 months after that, launching the mainnet. So the current status, as I said, we're working towards building our enterprise server. It's basically a single shard, and we've added the capability for the nodes to discover the network, to join the network, to sync up, to process the transaction and achieve consensus. We've this quarter added some capability to be able to resync. If you get out of the network and you have to join back in, you can resync to the network. And so what that allows us to do is add rotation so that the network can decide which node gets kicked out and, and come back in again later. Also, we've added the ability to do load detection, so nodes can recognize the amount of traffic that's passing through the network, and based on that, they can do some rate limiting. So you can have scenarios where you have a lot more transactions being thrown at your network than what the network can handle with its current size. So if you don't recognize and do some rate limiting, you're gonna end up with the scenarios that we have right now with Bitcoin and Ethereum, where they just take in every single transaction that comes in, but your transaction might be sitting in the queue for days. And then eventually people end up like, oh my God, I just want to cancel that transaction, right? So with our network, we'll be processing things within a few seconds, but if we're not able to give you that guaranteed time, we'll actually tell you right away that, hey, the network is busy, try again later. And then we also use that load detection to determine what the size of the network should be. So as the load increases, the network will want to increase the size and add more nodes to the network. One other thing that we've did this quarter is we've moved the Shardus tokens so that they can be exchanged on a decentralized exchange called YunaSwap. And that it's a fairly new exchange. It's completely decentralized, but it doesn't have a lot of software available for it. So we've had some of our developers create a web widget for it, as well as a Ethereum wallet which integrates with the YunaSwap exchange, and we've made that software open source and contributed back to the YunaSwap project. And if you go to shardus.com/wallet, you can actually see that wallet and experiment with it. We've also added what's called HMAC signatures to the Shardus backend. So that allows us to do faster signatures. And we've also improved our network monitoring tool that we've built. So we've added more features and increased the performance of that. Also this quarter, we've done some presentations to increase the awareness of Shardus in the Dallas community. We've attended the Dr. Bitcoin meetup at UTD, and we've also presented at the Dallas Startup Week blockchain track. And we've partnered with a marketing firm that's based out of Dallas here. It's called Global Blockchain Network. And they're going to be helping us in terms of increasing the awareness of Shardus within the blockchain and cryptocurrency community. Our plan for the next quarter is to finish up something that we still have to do on the enterprise server, which is detecting nodes that just go out. So, detecting nodes that are lost or nodes that have gone rogue and are not actually cooperating with the network. The network should be able to detect that and kick out those nodes. So we have to still add that feature to the enterprise server. And once we've done that, we'll be focusing completely on the global server, which is the key thing to the global server is the sharding capability. And once you add sharding, you also have to deal with routing the transactions appropriately. You have to deal with cross-shard communication and getting consensus across shards. You also have to deal with repairing partitions that may have gone out of sync. And then also, you just can't use your node to do the archiving because your node may not have all of the data. So you'd have a different set of nodes which can contain all the data, and those are referred to as the archive nodes. So those are the things that we're going to be building this coming quarter. And we post how things are going in terms of our token distribution. If you go to the Shardus website, there's a link there for our wiki. And in the wiki, we post each quarter how much tokens have been distributed. So the two columns on the left there show the estimated token distribution, and then the two columns on the right show the actual distribution that we've done. So far we're still under budget, almost like 50% under budget. And so we distribute the tokens using a nominal price of 10 cents for token. And so currently there's about 10 million tokens that are floating. And so that puts the market cap of the whole project at about $1 million. And we project that by the time the project is completed, there'll probably be about 40 million tokens out there. And a big chunk of it will go towards doing some marketing to get more users onto attracting them to the Shardus technology and helping them understand what we're building. So it'll be used in terms of marketing. And looking at it that way, our market cap, when the project is completed, assuming that the token price is 10 cents, would be about $4 million. And any of you that are familiar with the space know that similar projects that are out there have market caps in like the hundreds of millions of dollars, and some even in the billions of dollars. So this is our core team of developers, really awesome guys. They're right here behind me, if you guys could stand up. So we have 5 guys here in Dallas. So Amir is actually my son, and Derek. Derek is a really a close friend, and has also been programming since he was like really young. Awesome programmer. And Andrew, I've known Andrew from my Zynga days, and we've worked together a lot. Andrew's one of the core developers on the Halo Wars project, and he's worked at Microsoft and Zynga and developed some awesome game technology. And Samir's my brother-in-law, and we've worked together for many years as well. And Samir's worked at Yahoo, at Office Max, Cisco, many companies, and he's got a lot of experience in terms of building scalable systems as well. And then we actually have about 10 guys worldwide, but 3 of them that are working with us directly, and then 7 more that we use on a contracting basis as needed. So we've got a really awesome team, and we're committed to developing this project and getting it out there. So with that, we're going to move into the demo phase of today's presentation. So we're going to launch a network of nodes live right now on the AWS Amazon's web service. So we're using a bunch of EC2 nodes. We're going to be using 5 data centers across the world. And we're using, as you can see, like T2 micros, which are not very powerful computers at all. But we're limiting ourselves to that to show you that you don't need really powerful computers to run this software. And people can join these kind of networks using off-the-shelf computers. So we're going to launch 20 nodes along with 1 seed node. And the nodes are going to demonstrate how the network auto scales, how the nodes rotate in and out, and how the network will do rate limiting so that if you throw lots of traffic at it, it doesn't just like lock up all those transactions in the network and process them hours or days later, but instead gives you a response back right away. And we're going to go to about 50 TPS, and that's not a lot, but that's partly because we're using nodes that are not very powerful. So if you were using much more powerful nodes, you could, easily go up to like 200 plus TPS. So the setup of the demo is basically, we have various different clients. You can have a mobile client. We have a stress test client that, shoots a lot of transactions into the network. We have a command line client that, we can just inject any kind of transaction we want. Those go into the network, and then the network, each node in the network reports its status to a monitor server, and then a front-end web-based monitor client can talk to that monitor server and get the status of what's going on in the network and display it for you. So with that, I'm going to switch over to showing you the monitor client. All right, let me do a refresh here. So Samir's already launched a set of nodes up there, and each of these circle represents one node. And within the circle, you'll see like 3 smaller circles of different colors. Those circles represent various different state of the node internally. So for example, each node has a node list, it has a cycle marker, and it has the complete data. And so we take the hash of each of those and color code it in order to show what the state is internally of the network. And so when you see all the nodes having the same color there, that shows you that they're all synchronized. And you can see that even with nothing going on, the network will rotate nodes through it. So you'll see like some nodes getting kicked out, and then these other nodes that you see in gray, those are nodes that are waiting to join the network. And so periodically they'll submit a transaction to the network saying, I'd like to join. And the network will randomly pick one of those 2 nodes and allow them to come in.
Why do they get kicked out?
The ones that are already in the network, they get kicked out based on how long they've been in the network. So the nodes that have been in the network for the longest time, that node will get kicked out, and a new node will be allowed to join in its place. Samir, you want to put some transactions into the network? So you can see here, there's 3 nodes that are waiting to join the network, but the network only wants about 15 nodes. It's currently got 17 nodes, so it really doesn't need more nodes. But if we start throwing some traffic at it and increase the load, then the network will start allowing these other nodes to come in and join the network. So when Samir starts putting the transactions into the network, you'll see those coming in as like little red dots. So each transaction is a red dot, and then that dot will go and get distributed to the other nodes in the network. So that's basically the network telling the other nodes about the transactions that they've seen. And as you can see, as it's happening, the nodes are not synchronized. At any given time, they may be out of sync, but eventually they'll reach a consistent state. So that's referred to as eventual consistency. And over here on the right, we can see that we're up to like 45 transactions per second. And some transactions are getting rejected, so the network is going to want to increase its size. And above that, you have like the number of nodes that are joining, the number of nodes that are syncing, how many are currently active, which is 15. Now the network started out wanting 15 nodes in the network, But now you've seen that that number has increased to 16 because it's recognizing that there's a lot of traffic coming in. And that, whoops, let me just set that up here.
So are those GPU nodes? Are they CPU nodes?
They're all CPU nodes. So you don't need, you don't need any GPUs in the network. And now you see the desired number of nodes has gone up to 17. And as we keep this load going on the network, that number will continue to increase. And you can see that a new node has just been allowed into the network. So it'll have like a yellow color. And while that node is still syncing up with the network, it'll have a yellow color, meaning that it's not actively participating in consensus, but it's pulling data from the other nodes to synchronize itself with what the current state is. And once it's pulled all the data and gotten synchronized, then it'll turn to a green color to indicate that it's now active.
So I was assuming or thinking if you add nodes, since this is a single shard, if you add nodes, it slows it down.
Yeah, you're absolutely right. This is not gonna help adding more nodes when you have a single shard. But we're designing it that way so that when we have multiple shards and it does increase the number of nodes in the network, it will help. So yeah, you're absolutely right. With a single shard, it doesn't matter if we have 10 nodes or 100 nodes. It's really not going to get any better because every transaction has to get propagated to every node in the network. So that's a really important point. But when we do have sharding going on, different groups of nodes will be in different shards, and so the transactions will be routed appropriately to different shards. And in that scenario, it does help to increase the number of nodes in the network.
And so in a single shard, when you say that it's proof of quorum, it's essentially, does that equate to voting?
Exactly, yeah, so.
That's what will always limit a shard. That's the scale problem in a shard, is the messaging of the voting.
Right, exactly. So so when you have like voting, it's really hard to do that if you're going to have like 1 million nodes in your network. Just passing around the votes of every node in the network is just going to bog you down. So it makes sense to have your shards of a limited size, but the number of shards can increase. And so that's how we scale, and that's where we still benefit from having this very efficient, energy efficient way of doing consensus based on proof of quorum, but yet we can get a lot of nodes in the network. So now you can see the desired number of nodes has gone up to 20, and all the nodes are now allowed in the network. And there's currently 18 active nodes. There's a few more that are continuing to get synchronized, but now that we've stopped the traffic to the network, you should see that desired number of nodes start to decrease from 20 back down to 15. And we've set 15 as a minimum number of nodes that the network should have. So in fact, if the network size got to be less than 15, it wouldn't process transactions at all. It would just return back a response saying, the network is too small right now, right? So that's a better thing to do than to let the network shrink down to a very small size where you don't have legitimate consensus. So yeah, you can see that the desired now is starting to come down to 18.
While you have your transactions going on, if the number of nodes that are going rogue, right? Let's say you have a number of nodes going rogue. Will there be a process to identify immediately, and is there any liability in terms of if a lot of nodes go rogue?
Yeah, there is a lot of liability if a lot of nodes go rogue. So one of the key things to all these peer-to-peer networks is the fundamental fact that you need to have at least a majority, 51% or more of your nodes being honest nodes. If you can't satisfy that, fundamental sort of like axiom of peer-to-peer networks, then your network is not trustable. So, for different types of attacks, it varies. Some attacks you can get away with having 51% of your nodes be honest nodes. Other types of attack may need you to have 2/3 of your nodes be honest nodes. So yeah, that's a very important point. And you can have some nodes go out, you can have some nodes becoming rogue. And one of the nice things about our network is that it will identify those kind of nodes and remove them from the network and be able to keep the honest nodes and the nodes that are active in the network.
So a related question on the auto scaling, and I think I heard you say that you will add, like Shardus will add nodes, your own nodes, but then if there's enough public nodes, then you just take your own nodes out. Was that?
So auto scaling is basically what you just saw here. So Shardus just provides the foundation for this software so that anybody writing an application.
Is Shardus going to have a set of nodes out there that you will add to the network?
No, we don't run the nodes ourselves. The community will basically take the Shardus software, develop whatever application they want to develop from it, and then they'll put out their own software that people should download and run these nodes. Yes?
So let's say if you're talking about hundreds of nodes and probably millions of transactions, in terms of time, any idea how much would it take for eventual consistency?
So when we have like a large number of nodes, the network will automatically divide itself into multiple shards. So for example, if we had, say, 10,000 nodes, we could have 1,000 shards with 10 nodes in each shard. And the consensus only needs to be done within each shard. And so what you saw here is, basically that kind of consensus being done in one shard, right? So the time for transactions to reach consensus with a network like this is going to be in the matter of seconds, as opposed to
so
like.
You have two eventual consensus. You have one that's within the shard, but then you also said you have the complex transactions coming, which is across shard. You have to achieve eventual consensus across shards at some point as well, right?
Yeah, absolutely. So transactions that go across shards would probably take a little bit longer. And basically what you have is a scenario where a complex transaction refers to multiple accounts that are in different shards. And you need each shard to tell you that, hey, this guy actually has the funds within the account, for example, to be able to carry out this transaction. And so you'll have each shard do consensus, and then the shards cross-communicate to let each other know the result of their consensus. And then based on that, you can create a bigger receipt that can be used to prove that the transaction was accepted or not.
You mentioned archive servers.
Yeah, right.
Does the mainnet or this part, does it keep any history or?
No, so the main network will only really keep the current state of the network, along with some history of transactions that it's seen.
For a time frame, you mean?
Right, for some amount of time frame. And the reason for that is because each shard won't have the complete data that it needs to for the whole network. But there will be archive servers that call into these nodes to get the list of transactions that have been applied.
Yeah, so the Libris, is that what
Libris.
Libris, that will, it's just holding balances, account balances essentially.
Right.
With a little bit of a time frame of some of the transactions.
Right, yeah, so in the Libris network, the nodes that are actually doing the consensus will only be holding the accounts and balances with a little bit of history, but then the archive servers for Liberdis can hold the whole transaction history. So, yeah, as you can see, the desired number of nodes has now come down to 15, and nodes are starting to get rotated around again. And you can see from the colors of the smaller circles within each of those nodes that all of the nodes have a consistent state across them. So, yeah, so thanks for that, Samir. All right. Now, we actually have a web wallet too, so you know, if people want to try it out and send transactions into this network, you can. If you go to w.shardus.com with your web browser, there's a little wallet there that you can use to actually create yourself some coins and then transfer coins between people. We've done that at some of the previous demonstrations, and when you send a transaction, you'll actually see it come here and then, you know, move around through the network. But since we're kind of running a little bit slow on, on time, I'll probably skip that part. So yeah, so you saw that demonstration, and we have a wallet that you could actually use to try out that. And finally, you know, you've heard about Shardus, you've heard about the tokens. You know, we're giving about 200 tokens to everybody. That comes out to about like $20 worth at a 10 cent per token kind of nominal value. So just you know, use your mobile phone or browser to go to w.shardus.com, port 5000, and then just, you know, just enter your name, email, and your Ethereum address there, and we'll send tokens to you. So please note that down and try it out, and you'll get some Shardus token. They're actually on the Ethereum network, so if you're familiar with Ethereum, and if you've, you know, acquired other tokens, you'll see that this is a very similar process. So for more information, our website is shardus.com. We have frequently asked questions there. There's a wiki which has a lot more details about how the project works and so forth. There's a white paper, and then there's social media links. So if you can, you know, join our social media channels, that would help us out. And, you know, I just want to say that basically, long term, we are doing this project as, you know, sort of something that we think that is really going to be needed. I think, you know, because we're working on this software right now, it's going to put humanity a few years earlier to getting where we need to get than if, you know, we hadn't worked on this. Because, I mean, you know, humanity gets there eventually anyways, but we just like bounce here and there and slowly get there. But sometimes, you know, if you have a vision and, you know, an idea about where things are going, and you feel, you know, motivated to try to get us there, you know, it's like Steve Jobs says, you know, don't just wait for somebody to do it, just get out there and do it yourself. And so that's the kind of feeling our team has. And of course, you know, community is a big part of that. And, you know, we definitely need support from you guys to help make this happen, and, you know, become a part of the Shardus community. And long term, what we want to see are some of those projects out there, like, you know, a global stable currency, you know, decentralized identity networks, you know, these kind of incredibly awesome, you know, public utilities can only be achieved if somebody has a vision to build these kind of networks. The networks that are out there currently are sort of, stepping stones really to getting to where we need to go. And, so Shardus is not trying to get there like really fast. We're trying to slowly and methodically get there so that when we get there, we have a network that can really handle billions of users, can really handle millions of transactions per second. So thank you very much for coming, and if you have any questions,